Namaste everyone. Welcome to the project demonstration of our major project titled Dynamic Simulation of 2D Static Physical System. First of all, let us talk about the problem statement. It is very difficult to conduct physics-related experiments in a lab setting because of several constraints. It requires a large amount of resources, including space, equipment. There are safety concerns, and it takes time to set up those lab experiments as well. And scalability is also an issue. So, what are the existing systems solutions? So, there is an online platform called My Physics Lab, which provides predefined simulation environments, but it has no customizability. We have another existing solution named Symfy software, which is highly customizable, but it is too costly for students and teachers to afford. So, what does our solution do? It models and simulates those interactions and motions of objects in 2D environment under the influence of various physical forces. The types of physical systems that can be simulated in our solution are pendulum motion, mass spring system, rigid body dynamics, and ramp systems. So, what are our design choices and design approaches? We have used C++ as our base language. We have used OpenGL for rendering. I am GUI for controls, Box 2D for rigid body dynamics, and we have used helper libraries as well. So the design approach is object-oriented programming. We have used OP for inheriting the properties in our world system and for creating different items. And we have inherited primitives from those item classes. So let us talk about our system architecture. It is a mix of layered and modular approach. First layer is OpenGL rendering API that provide us with lines and triangles to display complex objects. The second layer is composed of three important modules, namely a windowing system, rigid body simulator, and object rendering. The windowing system is GLFW. The rigid body simulator applies a Newtonian physics to calculate forces, velocities, and collisions. And the object renderer directly interacts with OpenGL rendering API to visualize the simulated objects. The last layer or the upper layer consists of all those components that interact with UI and user input. So let us go towards our code implementation. As you can see, we have the main .cpp file under the root directory. Let us run the code. So this is our simulation environment. So we have different UI elements. We have the toolbar that consists of file, items, analytics, and edit properties. The edit property helps us to change the lightings, colors, fonts of our simulation environment. The menu bar consists of all those primitives that are provided by our system, such as block, ramp, ball, surface, wall, and spring system, pulley system, rope system. In our simulation environment, there are two kinds of bodies: static body and dynamic body. Dynamic body responds to the simulation properties such as gravity, friction, but static body do not respond to such physical properties. On the left hand side, you can see the properties of the selected objects. If we select an object, we can see its mass, which is in kilograms, density, its position within this simulation environment, and its terminal velocities as well. We have a timer agent that measures the simulation time, and we can tweak the gravity of this entire system. Currently, we have 10 meter per second square. We have reset and delete functionalities as well. So once we press enter, you can see the dynamic bodies respond to the physical properties such as gravity and coefficient of friction. We can save this entire environment setup in a file. We have used a JSON structure to serialize the information of those experiment setups. We can export, we can reset, and then we can import the system. So this is our demonstration video. Thank you for bearing with us.